Hello everybody and welcome to this episode of Programming and Algorithms. In this episode we'll continue looking at arrays and we'll look at how to search an array for a specific value. So let's run our program here to print out the values of the array. And let's say we want to see if the number 18 occurs in this array. Well, we can see it happens twice, but let's write a program to do it and we'll call it sequential search. What we'll say is if a particular element in the array, let's say age n is equal to 18, colon, then, well, we can say that'll print out 18. Alright, let's run that just to see that happen anyway. So it's found 18 twice, but let's tell it at what position they're at POS n. So 18 is at position 4, that is, it's the fifth element of the array, and at position 7, which is the eighth element of the array. Let's actually make it clearer by saying at age, at that location in the array. Different position maybe. Beautiful. 18 is at age 4 and age 7. Just to say, we call that a sequential search because we start at the start of the array and go as far as the end, and we keep on searching until we find the element we're looking for. It's considered a very complete searching approach, but nonetheless it's not very fast. So if there are other algorithms, other approaches we can take that are faster. And the one we might look at is called binary search. So let's change the name of the program from sequential search to binary search. And I suppose the key thing to note about binary search is our array here is unsorted, that is, it's not in any order. For binary search to be effective, it has to be sorted, so it has to be in numerical order. That's just the rule with binary search. So that's how once it's ordered, it will jump to the middle of the list and look to see if the number you're looking for is less than it or greater than it. If it's less than it, then it'll discard the top half of the list and just look at the rest of the list, and then jump to the middle again and check if it's less than it or greater than it. If it's less than it, it'll discard the rest of the list and then it'll quickly zoom in on what you're looking for. So it's very fast and very efficient. So the code for binary search is as follows. Yup, I'm not going to type it in, I'm just going to paste it in. So we get a value. We have the first element of the array as being 0, and the last element as being the length of the array. We keep on going as long as we haven't reached the middle, and we still haven't found it, so we declare a boolean is found to be false, and we keep on looking until we find the array, the element in the array we're looking for. We have a middle index called middle, so we integer divide the sum of the numbers by 2, and then we check if the value we're looking for is the middle element first, and if it's not, if it's less than it, we move the last element to be the middle element, and if it's greater than it, we move the first element to be the middle element plus 1. So let's save this and run it. And then if we're looking for the number 18, well, let's help ourselves out a little bit by printing out the array first. File save and file run. So if we're looking for 18, it jumps to the middle, and says it's less than it, jumps to the middle again and says it's less than it, and then it finds the value. We could print out where it finds it, things like that, no problem. So all we'd have to do is put in here something like at position. What position would it be at? It would be at position index, really. So save and run. So 18 again is found at position 1. That is to say, it's found at that position. If we want to find it at a number of positions, we can do that as well. That's no problem. But this one just finishes as soon as it finds it once. So that's binary search. The two kinds of search we've looked at are sequential search and binary search. Sequential search means start at the start of the array and look at till the end. Binary search means jump to the middle, look if the number is less than or greater than the one you're at. If it's less than it, cut off the top half of the array. If it's greater than it, cut off the bottom half of the array. Then jump to the middle of the rest of the array that's left. Do the same process. If it's less than, cut off the top half. If it's greater than, cut off the bottom half, and keep doing that until you get to the end of the array. Thanks very much. We'll see you on the next episode of Programming and Algorithms.